this video, we're going to look at the section 10.1 examples. We're going to start with this problem. In how many ways can a club with 5 members, Alan, Bill, Kathy, David, and Evelyn, select a president if all members are eligible? Well, this is pretty simple because there are 5 members, they're all eligible. There are 5 ways to choose the president. It's either Alan, Bill, Kathy, David, or Evelyn. Determine the number of different possible results when 2 ordinary dice are rolled. Well, we can roll 1, 2, 3, 4, 5, or 6. 1, 2, 3, 4, 5, or 6. So we get 1, 1, 1, 2, 1, 3, 1, 4, 1, 5, 1, 6, 2, 1, 2, 2, 2, 3, 2, 4, 2, 5, 2, 6, 3, 1, 3, 2, 3, 3, 3, 4, 3, 5, 3, 6, and so on. But the question is, are all of these unique? Are these all is 1, 2 different from 2, 1? In each case, we're getting a 1 and a 2. This is where I check what the book actually wants us to say here, because it can go either way depending on the way that people want us to look at this. And the answer is yes, they are different for purposes of our book. So clearly for 1, for 2, for 3, for 4, for 5, for 6, and we're going to count all of these. So we see that there are 6 possible results on one die, 6 possible results on the other, give us a total of 36 possible results. Which is just a matter of multiplying the numbers. Now we return to that same club where we had Alan, Bill, Kathy, David, and Evelyn. We want to find the number of ways that the club can elect both a president and a secretary if all members are eligible and no one can hold both offices. So we have 5 candidates for each office. We'll call this the president position. Here's our secretary. Okay, well, Alan can't be both president and secretary, so we can cross that right off. But Alan could be president and Bill could be secretary. Alan could be Alan could be president and Kathy can be secretary, AD, AE. And Bill could be president with Alan secretary, but Bill can't be both president and secretary. And what we see here is that there are 4 possibilities per row. One of the possibilities is eliminated because person can't hold both positions. CA, CB, not CC, CD, CE. In other words, we have 10 possible combinations here and 10 here. for a total of 20 ways. Now we're asking how many ways can Club N appoint a committee of 2 members to represent them at an association conference. So again, we set up our table, A, B, C, D, E, A, B, C, D, E. And I'm going to point out something here before we move on. When we look at the president and secretary combinations, order matters. It matters whether we have AB or BA, because AB implies that Alan is the president and Bill is the secretary, while BA implies Bill is the president and Alan is the secretary. On the other hand, while we still can't have AA, BB, CC, DD, EE, Alan being one member and Bill being the other is the same as Bill being one member and Alan being the other. So BA and AB are the same, and we only count each combination of 2 people once. That means that fully half of the possibilities for president secretary are invalid here. We're only going to have a total of 10 ways to appoint a committee, as opposed to the 20 ways we had to choose a president and secretary. Now we're going to talk about tree diagrams. Pamela's computer printer allows for optimal settings with a panel of 4 on-off switches in a row. How many different settings can she select if no 2 adjacent switches can both be off? So what we'll do here is we will start by labeling our choice for the first switch, second switch, third switch, and fourth switch. Now, if the first switch is on, I mean, we have 2 choices for the first switch. Either it's on or off. So if it's on, then there are 2 possibilities, because after an on, we could have another on or we can have an off. But if it's off, there is only one possibility, because no 2 adjacent switches can be off. This is on. So this can be on or off. But this can only be on, and this can be on or off. Okay, it's on, again, on or off. Off means it has to be on. On can be on or off. On can be on or off, but off means it has to be on. 1, 2, 3, 4, 5, 6, 7, 8 possible ways to do this. Anne, Babette, Chuck, and Deirdre have tickets for reserved seats in a row of a concert. In how many ways can they seat themselves if, sorry, this is Arnie and Babette, not Anne and Babette. If Arnie and Babette are seated next to each other? Well, again, we'll use a tree diagram. What it comes down to is this: there are only 3 ways to seat the 2 of them together, and after that, it's order. They can be seated in the left 2 seats, the middle 2 seats, or the right two seats. Then we can have Arnie sitting to the left of Bobette, or Bobette sitting to the left of Arnie. Once we've done that, now we have to figure out where Chuck and Deirdre sit. Well, there are only two places for them to sit. And again, it's left or right. I really need to make my tree diagrams with more space between the branches, but I always forget. Okay, but once we've done that, we can see there are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 ways for them to sit. And we don't have to state exactly what those ways are. We could if we wanted to, but we don't have to, so let's not bother. Last problem in this video, how many different triangles can be found in the figure below? I find the best way to handle this is to start at A and go to B and then to C and then proceed that way. So I can start listing the different ways that I can make these triangles. So there's my first triangle, ABC. Likewise, I can go ABD, ABE, that's fine. And we've got ABF. This is systematic listing. Okay, I've done everything I can with A and B, so now I go ACD. And I go ACE. But I can't go ACF because they're all on the same line. That wouldn't make a triangle. I can go AD, but I can't go ADE because they're on the same line, and I can't go ADF because there's no line between D and F. So that's everything we've got. We've got AEF. So that's everything we've got that includes an A, and now we move on to B. I can't do BCD because they're all on the same line, but I can do BCE. And I can do BCF. I can do BDE. But again, can't do BDF because D and F don't have a line between them. So that's it for my B's. I move on. Oh, and I can't do BEF because they're all in the same line. I move on to C. I can do CDE. I can do C. I can't do CDF, but I can do CEF. And that's it for my C's. Now, I can move on to D, but there is no triangle I can make with D, E, and F because there's no triangle I can make with D and F. That means that this is the complete list because we don't have a connection between those three final points. Okay, so we just count the different triangles, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. There are 12 different triangles. That's it for this video. If you have any questions, please get in touch.